This is the video introduction to Experiment 9 in the Mr. Circuit Basic Electronics Lab 1. This experiment will demonstrate how a PNP transistor works. Here is a picture of a 2N3906 PNP bipolar transistor like the one you have in this lab. This transistor is made of black resin and has 3 leads or wires coming out of it. With the flat side of the transistor facing you and the leads pointing down, the leads are called from left to right emitter, base, and collector. Be aware that although the 2 transistors we use in this lab have these pinouts, not all transistors have the emitter, base, and collector leads in the same order. Note that the sum of the base and collector currents is equal to the emitter current. It's the same for both NPN and PNP transistors. Here is the page for Experiment 9 in your lab manual. Notice that there are 3 subtitles: Purpose, Procedure, and Results. The purpose of this experiment is to observe how a PNP bipolar transistor works in a circuit as a current amplifier. This circuit will also serve as a transistor checker for PNP transistors. Procedure: using the parts from your Mr. Circuit lab, build the circuit on your solderless circuit board as shown in the pictorial diagram. Compare the pictorial to the schematic diagram. Results: when you connect a 9-volt battery to the assembled circuit, the LEDs in the circuit should not light up. But when you press the push-button switch, allowing current to flow in the base circuit, current will also flow in the collector circuit. So what you see is both LEDs will light up. But you will notice that the LED 1 in the base circuit is a little less bright than the LED 2 in the collector circuit. What this demonstrates is that a smaller current in the base circuit is causing a larger current to flow in the collector circuit. We refer to this as amplification. Here's experiment number 9 for the Mr. Circuit 30-in-1 lab, and I've wired it all up following the pictorial diagram and the schematic, and this should demonstrate how a PNP can work as a current amplifier. Now this is going to be the same kind of experiment similar to the NPN transistor. The only difference is the direction of the current flow. Now before we had the current coming out of this lead, but this time I've got the black lead over here, and the current will enter the 2 resistors, the 1000 ohm, then it will go through the switch and then back over through the LED to the base. And here it will go through the resistor, through the LED, and not to the base, but in this case to the collector. So the collector is the lead over here on the left, then you have your base, and then you have your emitter. And the base current plus the collector current add up to the emitter current. So if we've wired this correctly, when I turn on the switch, the base light LED should be dimmer than the one for the collector. So let's try it and see. Okay, so here we go. Oh, there you go. You can see that the LED for the collector is brighter than the LED for the base. So a PNP transistor will also work as an amplifier. Now go ahead and get your parts and wire up this experiment on your solderless breadboard to make sure you get the same results that I did.